Today we're going to talk about the input side of the ladder diagram. And to make sure we understand fully a ladder diagram, if you look, there are lines that are part of this ladder diagram that we call a rung. So this would be the first rung, the second rung, third rung, fourth rung, and fifth rung, respectively here. And when we put all the rungs in, it kind of looks like a ladder because we have the rails on each side. So let's talk about the left side, but before we get to the left side, let's talk about these devices. Anything with a circle is a load, it's an output, it's something we're trying to turn on. So you can see here, this is a lamp. These are control relay coils, and this is a motor. So we're not going to talk about those outputs over here, but I did want to at least not ignore them. We're going to be talking about the left-hand side of this, which everything prior to the output is what I'm referring to as the left-hand side. And these are going to be composed of switches and relay contacts that we see here. So for instance, PB1 stands for push button 1, that is a switch. PB2 stands for push button 2 is a switch. And then we have all these relay contacts, these vertical parallel lines. And if you notice, some of those vertical parallel lines have a diagonal line through them. So let's talk about that. So the entire idea of a ladder diagram is understanding how we turn on these outputs. Well, we have to use inputs to turn on the outputs. So basically, if you look, the right-hand side of our lamps are already connected to our negative side of the source. And what we're trying to do is provide a pathway through our inputs to the from the positive side to our source. So once we put our positive voltage on this side, we already have our negative side here, our source will turn on, or our relay or our light or our motor, whatever the case might be here. So the one thing we need to understand is some switches are what we call normally closed, some are normally open, and the same is true for relay contacts. And we can quickly identify this with just a little bit of training. PB1 is closed already. If you look, you'll see the two little circular contacts down here. The switch is already closing those contacts. So what would literally happen is, as soon as we powered on power to this particular device, because the switch is already closed, is our current's going to flow. Let me get a blue pen here, and let me get a good sized brush. Current's going to flow through our positive, through our push button, and over here to our control relay, and that control relay coil is going to be energized. And that's because this button, without any intervention on our part, is already closed. So it's normally closed. Now this push button is normally open. If you look, you'll see a difference. We've got power running to this side, but notice this little line that's part of the switch is not connecting those two little circular things together. So this is what we call a normally open switch. It requires an operator to intervene to close it. As soon as they close it, the same thing would happen. Power would come over here to CR2, and that coil would also be energized. But there is the difference between normally open and normally closed. This one is normally closed. It sits in the closed position. And this one is normally open. It sits in the open position. And when I say it's open, I mean it's not providing a path from this point to this point. When I say this one's closed, it is providing a path. Now these control relay contacts here are going to change states based on the conditions of these coils right here. But they're just like switches. They have a normally open, and they have a normally closed. And it's easy to remember which are normally closed, because just like we know this switch is closed because this side is connected to that side, I can know this is normally closed because this side is connected to that side. So the only thing we have to know differently is that if CR3 is energized, the normally closed is going to not be closed. So to kind of reiterate that, a contact on a relay, the normally open contact like this one right here, it's normally open because it doesn't have a little line through it, so it's not closed, just like this is closed, this is closed. So these contacts change state based on the condition of this relay. So in order for CR1 normally open contact to be closed, CR1 has to be energized. Well, as soon as we power it on, CR1 is energized because we just talked about that unless we're pushing the switch. So literally what's going to happen is current's going to flow to here. It's going to energize the coil of CR1. And immediately that same current in really at light speed is going to go through this contact that is now used to be normally open, but because this guy energized, it's now closed, and it's going to energize CR3 just like that. So that's the difference between a normally open and a normally closed. So let's review that for just a moment in relation to our relay coils. A normally closed contact is closed if the relay coil is not energized, and a normally open contact is closed if the relay coil is energized. So again, these have to do with the state of the relay coil, just like these have to do with the state of our interaction. If I don't interact with this guy, it stays closed. If I do interact with this guy, it goes from open to closed. Same way is true here. It's just that we're changing some states of some relays in order to make that happen. So let's talk about a little bit more that we're seeing here. So after you spend a little bit of time, and I know we said we wouldn't talk about the outputs, but we really kind of have, and you really can't help but to. We know that as long as PB1 isn't pressed, CR1 is going to energize. So that's easy. Now we also know if I press PB2, CR2 will be energized, but if I don't, it won't. Now the state of CR1 and or CR2 have an effect on whether control relay 3 coil is going to be energized. And the state of that coil has an effect on whether this lamp is going to be energized. And we see a different condition of CR1 and CR2 here. Well, remember, the idea is to move current through. So it's kind of like water flowing through a pipe. So we know as soon as we power on the entire system, we're going to get flow over to CR1. And CR1 is going to be, the coil is going to be energized. Well, that then takes this normally open contact and it closes it. So we've got current flow here, and CR3 is going to be energized. Now again, that's as soon as we power on the system. Now this says if CR3 is not energized, or if it's in its normally closed position, which means CR3 is not energized, then L1 is going to be on. So get L1 on, we're going to have to come here, and we're going to have to, let me get a red pen, we're going to have to move this switch, not close it, we're going to have to open it. We're going to have to move it from the normally closed to the normally open, which is then going to de-energize this relay. And when that relay is de-energized, this contact, which was open and closed because it was energized, is going to reopen. And that means CR3 is no longer going to be energized. And when CR3 is not energized, that means we're going to have movement through here and turn on L1. So it's just similar to reading a book, left, right, up, and down, and following the signals, following the paths. The only difference here is I want you to I'll provide you an answer in the next video, but I want you to think about what is the difference between having this CR1 on top and bottom of one another as opposed to having them in left to right. And there is a difference electrically. So just to recap, normally open, normally closed. Normally open relay contacts are open until the coil is energized, and normally closed relay contacts are closed until the relay coil is energized, then they open. That's it.